Hello friends and hello student. My name is Ashok Sijala. In this session, we learn the shell sort in data structure using C language. So let us start. First, I share my laptop screen and fix the position here so you can watch better my video lecture. And here, first, we have to understand the theory part in my book. So shell sorting. This sorting is simple extension of insertion sort, and its speed come from the fact that it is exchange element that are far apart of insertion sort and interchange only adjacent element. So that is a extension of insertion sort, and we can find the gap. So first like 8, so divide by 2, so 4, then 4 divided by 2, so 2, and 2 divided by 2, so 1. So that at last adjacent element, so adjacent means near to element, and we have to compare. Shell short is also called the diminishing increment short or gap short or com short, developed by the Donald Shell. And shell short is based on the most recently shorted array element, and process is divides the array element into smaller part, which are then separate shorting using the insertion sort. So that is a base and so many different name like diminishing increment short or gap short or com short that developed by Donald Shell. So that its author name or the developer Shell short is very famous technique. So yes, let us check. So first, like there are 8 elements, and first n divided by 2. So n is 8 and divided by 2. So 4 gap. So first iteration or first table 0 to 4, we have to compare the two element and then exchange. If that element is smaller, so we can swap. And same 0 to 4 index, 1 to 5, 2 to 6, and 3 to 7 index, and comparison. So here is a gap is 4, and then we can start the comparison, and that gap between two element, and we can apply the insertion sort. So 79 and 23, that is a exchange in here 23 and here 79, that is exchange. Same process go ongoing. So after that is a because that second index, and here comparison. So I previously told you first to 5, 2 to 6, and 3 to 7 index is comparison. And then if smaller element, then we can exchange, swap the element. And then second iteration 4 by divide by 2, so 2 gap, and then we can compare the 0 or 3 index, 2 4 0 2 3 5 3 5 and 4 6. So that is a we can have to compare. Same 2 4 5 7 3 5 1 3, and then at the last you can look here, so 0 and 3, that is a swap, and then exchange because 12 is small and 23 is a greater number, so we have to means swap. And that's ongoing, this process continue to till the we have to find out at the last to a single gap. So at the last 2 divided by 2, so one gap, and each so near adjacent element compared to, so 0 index 1 1 to 2, that type of we have to comparison. So here first that comparison chart, and here we have to compare. So that is small 12 as remaining, then 2 here 23 and 31, so 23 smaller, 30 is remaining here. So 31 and 18, so 18 is come to go ahead. So you can look here, 18 is come to in the, and same that is insertion sort, so we can compare to the at the 0 again. So that continue process, yes, and ultimately last we have to find the whole array is a shorted. So you can look here, so 12 18 23 31 36, here last that exchange, and last 49 29 and 89. So that is all sorting in ascending order, and that advantage is it is simple and easy handle array element when element are arranged properly, and it is not efficiency for medium side list is only efficiency for medium size, not that means that not take large element. So that disadvantage for large list, the algorithm is not the best choice, and it is a complex algorithm and it is not nearly as efficient as the merge sort and quick sort. So that is my books, and then after I cover the program of shell short, and then after that's algorithm. So that is algorithm. Okay, now I think, and that complexity also I cover. So worst case, yes, and here average case and best case, and then bucket short is, so that I cover in upcoming my video lecture. So now we can start to our shell short program. So let us take. So yes, here I open Turbo C++, and then we have to perform the shell short program. So here our definition, so write a program to perform the shell short technique. Yes, it is a shell short technique. And then we have to start our header file. So stdio.h, and then yes, conio console input output dot h. Yes, and now one that is we can use direct malloc and calloc. So alloc.h, location.h, alloc.h, that header file. So perfectly. Uh, so that is a, we have to allocation. So yes, here C is remaining. So allocation.h. Yes, now perfectly allocation. And now what to do? So that is we can directly in the main function, you can also use the user defined function, but here simplicity I not take the UDF. First we have to as is, first we have to take as normal. So that is a pointer, then we can take I, J and K. There are three index, and one important is a temp and number of element n. And then clear the screen. Yes, now first we have to enter the our size. So enter, yes, 1D array size, that type of message, and we can scan the n variable. So yes, right, come to here. Okay, percentage d and then ampersand n. Okay, now what to do? So we can allocate the memory. So malloc or calloc, there are two functions. So that we can first n divide by size of operator and pass the integer, because that integer pointer. And here that return type is void pointer, so we can type casting. So that now complete malloc function, and we can pass only one argument. So that is allocate the memory perfectly. And now we can scan the elements. So first here I provide the message. So here you can say that enter, first capital enter 1D array elements. Yes, and we can take slash n, I equal to 0, I less than n, I plus plus, then what to do? So here I use always index to scan the our array. So percentage d and then I, and then scanf function. So percentage d and ampersand x of I. So that is our scanning. And then after we can also print by copy and paste, and then get ch. So first that is our input and output. So here not enter, but we can say that after shorted or shorting 1D array element R. So that type of message, and we can remove this index and that brace. Yes, here that index we have to also print. So colon and percentage d. Yes, here also I want blank and colon sign. So that is after, but in between here we can so I save that file first, so we can say that shell short. Yes, and short, but very big dot, so dot c. But here you can look maximum we have to provide the 8 character, but here there is a big, so we can give the only shell dot c, shell short. Okay, now yes, first let us check, and after that print we have to not forget, so that is a free function and pass the x, so that is a perfectly, and here we can provide the slash n. So let us check first. I compile, yes, there is no any error, and run. So I give the 5, so let us check. I give as randomly, not shorting, but yes, so look at that element. I alter F5. So yes, perfectly 2, 5, 6, 5, 4. So that is a we have to just scan and print, not shorting applies. Now in between, so that is our input, yes, and that is our output. And now in between we can apply to shell short. So take for loop means and I, yes, and divide by 2, because that is a first we can find the gap, so in that process, and then only not equal to greater I, then 0, and then I equal to I divide by 2. That is our first main for loop. So here we can take nesting, and there are 3 for loop we have to use. Then j equal to I, yes, then j less than and not equal to n, and j plus plus, so that perfectly. And now third for loop, so how, so we can take as k and j minus I, yes, and then k is yes, here first k is greater than equal to 0, and k equal to k minus I, that is our logic. And then if condition is required, so we can compare to our elements, so k plus I, yes, and then greater than equal to x of k, so that if condition is true, so we can, that is a break the loop, so only one loop is a break, that is only one inner that loop is break. And in else part, if not that is a greater than or equal to k of I is greater than equal to k of x of k, so x k plus I is greater than x of k, then we can take the, that is third inner, means second inner loop that we have to break. In else part, what to do, so we can apply to press, and then we can use as a temp, so that is not greater than, so we can swap, yes, k you have to store temp, and x of k we can take the x k plus I, and then x of k plus I equal to, we have to assign the 10, yes, so that is perfectly. So all loop we now close, so first that loop 4, and then this, and that is already completed, so that is our logic. Yes, here there are very simple but very important logic, so that is our logic. So yes, how this logic is applied. So you can do some paperwork. Then, like even in our iteration table. So first we can n divide by 2. So like n is 8. So divide by 2. So 4, and that comparison to each element. And here I equal to I divide by 2, because 0 index and directly 5 index, that element is comparison, and that is small, so that is a swap, and otherwise not swap. So after that is a, we can say that next, that our element, so n we have to say that only 4 that inner loop is starting and first iteration is table is completely, and so that n divided by 2 and I is greater than I, we can say that I equal to I divided by 2, and that is same process ongoing. That is a completely perfectly. You can also take the watch window and observation this how to find the gap of this logic. So here very simple logic we have to apply, and let us check. I first save and then compile. Yes, there is no any error. And yes, we have to enter the in my book that element. So I perfectly arrange that element. So which element? Yes, that I first write that input means how what is a input and output element. So that is perfectly. So yes, that I take the element in the my book itself. So let us I run and give the size is n 8, and then 23, that is first element, and 36, yes, and then 31, yes, then 12, that is then 79, yes, then 59, then 89, and last is 18 only. So that is a 8 element. And look now that perfectly sorted, yes, ascending order. So 12, 18, 23, 31, 36, 59, 79, 89. That is our sorting after 1D array element R. So yes, you can look here very easy way. First, we can find the gap. So that is a very simple way we have to apply to our logic. And there are 3 nesting loops. So only one iteration we have to take, otherwise there is very long session. So yes, first I only give the one and remove, because we have to take the watch window. So alter W, and you can look here watch window and then alter W and output window. So here we can take the first iteration table only, because there is very long session otherwise. So we can take only one iteration table. And then yes, here which element we have to. So first I take this screen to very small, and this watch window I can increase the size. So then and then we can see to all our element, and also that output window. Yes, now perfectly. And let us take first I set the watch window. So one iteration we have to take. So yes, you can look here. So first I take here, that is a x of k, then x of k plus I, that is our very important, and then temp variable, then I, then j, yes, j, and then k, yes. So perfectly all, and that is our 3 index, and that our swap. So here I start directly from here, not all. So I control F8 red line, so we can start the watch to directly our logic, and scan I directly. So control F9 I press and give the 8 element, and now again I input the same element. So that is I remember, so 20, 23, then 36, yes, that is my book itself. So I take top element, then 12, yes, then 79, yes, then 59, then 89, and last is 18. So that is a perfectly. Now what to do? So yes, first that you can look now our watch window is start, and first that is n. So yes, I also take the n variable. So n is 8, but n divide by 2. So I is now I think 4, because let us check. I press F7. So you have to know in alter R run menu, and here trace into, and that function key is F7. If I press F7, so you can look now, I is 4. Yes. And then j equal to I, so j is also now come to 4. Yes, you can look here. And then k, yes, j minus I, so j is I is 4 and j is 4, so 0 index, yes, so k is assigned to 0 and 0. And then here directly 4 means that 4 gap, so in between, that is, we can say that 0 index and 4, because n divided by 4, so that is a first we can compare to 0 and 4. Let us check. So here you can look, yes, that is a k plus I, so k plus I, so k is 0 and I is 4. So 4 index, that element is 79 and is greater than x of k. So that is a 20, 20, 23. Yes, that is 0 index. So yes, that is a greater than. So you can look here, if condition is a definitely true and the first inner loop is a break. Yes, directly. So directly that loop is break, and then go to directly here means k, let us check k minus I. So k is 0 and I is 4. So that is again means we have to say that first is you can look here, j is directly plus plus and come to in this loop. So this loop is false, but j is plus plus. So j is now directly here 5 and I is already 4. So that is a next time that loop is continue, and we can say that again comparison. So you can look, k is 1. So here k is 136. Yes, and then 59 5. So greater than or equal to k. Yes, that if condition is true, again so break, and then again j plus plus, so j is 6 now directly here this loop, and then again here j minus I, so j is 6 and I is 4. So you can look here, so k is 2. So 2 index is 31 and ki plus 1. So k is we can say 2 and I is 4. So that is a 6 index. So that condition again true. So break, and again j plus plus. So j is 7. So 7, and we can say that 7 index is 18, and then first j minus I, so j is 7 and I is 4, so 3. Yes, here you can look on 12 and directly 7. So that condition is not false. You can look here. So smallest, you can look here, first iteration 18 is smallest element, and that condition is if false. So else means yes, yeah, here 18 and 12, yes, that 18 is greater than 12. So that 3 index, yes, condition is again true, and j is now 8. So n is 8. So first iteration is now complete, because that j less than n, but n is 8 and j is 8. So that yes, so you can look here now that I is 2. Yes, I is first is 4. Now I is 2. So how it's possibility? So you can look here. So first I is n divided by 2. So n is 8 and 4. And now I equal to I divided by 2. So now second gap. First 4 gap we have to compare to each element. And now 2 gap we can access an element compare to. So that is a second iteration table is start, because first our main loop is started. So same process you can look here. I just show you one time. So here j minus I, so j is 2 and I is 2, so k is 0. So 0 index again 23 and k I plus 1, so k is 0 and I is 2, so 31 and 0, and that is 2 gap. So 0 and third index compare, and 31 is greater than of 23, so that is a break. Again same, that is j plus plus, so that is a continue. And here you can look now, if condition is false then as part go, and here 12 is not greater than, so here you can look 12 is not greater than 36, so 12 is smallest element and swap. So first time that as part is execute, and then again that is j plus plus, so j is 4 again, so 29, that 4 index, and k is 2, so 2 is 31. So yes, if condition is again true, so break j plus plus 5, same process ongoing on 59, and that is a 36, so 59 is greater than, loop is break j plus plus 6, same continue ongoing. So now I just, yes, now swap 18, so 18 is not greater than 59, so that is a swap. So when the small element, so if condition is false, then and then we can apply to the swap logic. So here you can look now, 18 is that is a 36, yes, again that is swap, and j7, yes, now that 18 is greater than 12, so again loop is back, and now second iteration is complete, and that we have to j not less than n, because j is 8 and n is 8, so now I is 1, so now third iteration, so that process is continuing ongoing. Yes, I just pass out, so but that is very long, so one index and all element compare, so if small element then swap, and otherwise loop is dead and j is plus plus. So that is completely, now you can look all element is shorted, and now print, yes, you can look in output window, so that perfectly. So that is a shell shot. So here very important that we can find the gap, and that based on the gap we can develop our logic. So yes, I remove this red line, so control F8, that, so here that n divide by 2, so n is 8 and 4 gap, and next time I equal to I divide by, so n I is 4 and divide by 2, so 2, and then 2 divide by 2, so 1, so that is a 3 iteration, and we can set the all elements, so that I think now you have to understand. So that is iteration and watch table. So both in my book I also first understand the theory part of the shell shot, and then we have to apply this logic. So here very simple way we have to develop this logic. So yes, any question regarding this shell shot, how to work? So here that is a gap and then comparison. So insertion sort, access extension of the insertion short, and that known as a shell short. So now I hope you can understand and enjoy this session. So regarding any question, any doubt of shell short, you can write in comment section. I give the definitely to answer you. Now I close this file, ref3, watch window and output, and quit. So subscribe my channel Ashok Sijalakani, press the bell icon to never miss any update, and thanks for your watching, supporting and sharing my video lecture, and Hare Krishna.